Okay, in this video we're going to talk about how you can use some clever coordinate trigonometry, that's trig in the coordinate plane, to actually avoid using the ambiguous case of the law of sines at all. To begin with, we have to know what the ambiguous case is. So the ambiguous case is when you know an angle, a side, and a side, and in picture form that looks like you know an angle, you know the side opposite the angle, and then you know one other side. And I pretty much always 100% set it up this way so that it's angle in the bottom left and then side opposite, and then the other side is always the top adjacent side, I guess you would say. So if you want to know more about the traditional way of solving that, my suggestion to you would be to watch the other video that I've already made on that topic, because this one's about avoiding that. So let's see what we can do. We're going to do an example and then kind of generalize it, and then I'll show you a couple of other examples. So say we know that angle A is 26 degrees, side A is 12, and side B is 20. So the first thing we probably want to do is we want to draw a picture, but we want to put it in the XY plane, specifically in the first quadrant. So this will be my picture. And then angle A is going to be at the origin, so that's 26 degrees, and then that must be 10, and then the other side is 20. Okay, so that's what we have so far. But there's more that we can kind of add to this picture. And so, for example, we can label this point. So we've already accounted for side A, which is 10, and side B, which is 20. The side along the x-axis is going to be side C, so I'm going to label this point C, 0, because it is C units away from the origin. Okay, so that's where we're going with that. That's going to be a really important point as we go through and try to solve this. We can also label angle B, because that's got to be opposite side B. We can put in a height, and importantly, this top point of the triangle, I'm going to label it Q. It's actually angle C, but it's a little confusing because I already use C, and lowercase and uppercase C look exactly the same. So I'm going to call it Q. And Q just has coordinates x of Q and y of Q, let's say. So the idea here is we really just want to find the coordinates of Q, because it turns out there are two ways we can do that. And so x of Q is in this little right triangle. It's that distance right there. It's the adjacent side to 26. And y sub Q is the height of the triangle. And our objective is really find the coordinates of Q. And to do that, x sub Q is pretty straightforward, right? We got a right triangle. We know x sub Q is the adjacent side and 20 is the hypotenuse. So we know that the cosine of 26 degrees is x sub Q over 20, which means the x coordinate can be written as 20 cosine of 26. And then we can do the same sort of thing for the y coordinate. So it's y sub Q is the opposite and 20 is the hypotenuse. So sine of 26 is going to be y sub Q over 20. And that means the y coordinate is 20 sine of 26. Okay, so that's one way of writing the coordinates. A second way uses basically the other right triangle. And there's a couple things we need to think about. So for starters, this whole distance right here is definitely C. And if I subtract kind of the adjacent side in that other right triangle, so specifically this distance, which I'm going to call R because that's a red line segment, and I'm clever like that. If we subtract R from C, we actually get x sub Q again. So if we can work out what R is, then we can write an equation. So if you just use cosine again, cosine of B in this case is R over 10, because that's the hypotenuse in that triangle. So C minus R is just C minus 10 cosine of B. We don't know what B is, but that's okay. And then we need to write the y coordinate again, but that one's a little more straightforward because the sine of B is y sub Q over 10. So we know the y coordinate is just 10 sine of B. So if you look at that, we've written the coordinates two different ways, and there's two unknowns in there. And if we just set the x coordinate equal to the x coordinate, so 20 cosine 26 equals C minus 10 cosine of B, That's x-coordinate equals x-coordinate, and then y-coordinate equals y-coordinate. So 20 sine of 26 equals 10 sine of b. And then we really, because it's a right triangle, not a right triangle, because it's a triangle at all, we want to restrict b to be somewhere between 0 and 180. And put that all together, we have a system of equations. So that's a system, and we want to try to solve the system. So on to the next page. So now I'm just going to show you some screenshots of how I solved that on my calculator. So I did menu 3.7 to solve system of equations. I told the calculator that there were going to be 2 equations, and my variables are going to be b and c. I typed it all in, and at the end, so I kind of scrolled over to show you this, at the end I did such that b is between 0 and 180. You definitely want to do that, otherwise you get some weird looking answers. So I'm limiting it so that b can only be between 0 and 180. You're not going to get any generalizations that way. And then I had it solved. And you can see that it actually it gave 2 sets of answers, because this is the ambiguous case and there were 2 triangles in this case. So the first answer, you can see b is 61.2519 and c is 22.7855. And then the second answer I couldn't really get in one shot, so I just copied and pasted it. It says that b is 118.748 and c is 13.1663, which is pretty cool. So we solved it without actually using the ambiguous case of the law of sines. We still solved the triangle. There's one more thing you would have to do by hand, or not by hand, you can do it by calculator, just have to be aware of this. You do still need to solve for angle C, but you can do that because you were given angle A and the calculator just told you what angle B is. So you're ready to solve for that with no problem. So I'm going to kind of go through this again in general just to show you what we did, see if you followed along. So we have this kind of generic triangle with angle A, angle B, side A, side B, the point C, comma 0, and then our generic point Q. Excuse me. So what we did was we wrote the coordinates of point Q 2 different ways. First using kind of the left-hand right triangle, where we got b cosine of A, whatever A is, and then b sine of A, whatever A is, and also whatever B is. And then we used sort of the right-hand triangle along with that line segment C, and we ended up with the x-coordinate of Q can also be written as C minus A cosine of B, and then the y-coordinate is A sine of B, which is just more direct. Turned that into a system of equations. So there is one other thing that you want to kind of watch out for. Your calculator sometimes will give you a negative value of C, but if you just think about it, that doesn't make any sense. So you can kind of discard that answer and not really worry about it. It's extraneous. So our system ends up looking like this. And of course we want b to be between 0 and 180. So here's our generic system. So now what I'm going to do is I'm going to give you a couple of cases to kind of play around with when you grab your calculator. So first of all, A is 52 degrees, side A is 25, B is 35. I'm just going to write down what the system would look like. So the system ends up here. So 35 cosine of 52 equals C minus 25 cosine of B, and 35 sine of 52 equals 25 sine of B. Got to be between 0 and 180. I asked my calculator to solve that. Calculator said false because this is a situation where those sets of givens don't actually create a triangle. So when that happens, your calculator is just going to tell you false, and you can move on from it. Let's look at another one. So if A is 38, angle A is 38 degrees, A is 50 and B is 44, we can write our system. So 44 cosine of 38 equals C minus 50 cosine of B, and 44 sine of 38 equals 50 sine of B, where B is between 0 and 180. I asked the calculator to solve this one, and this is one where it gave me that weird thing. So it gave me B is 32.805 and C is 76.6984, or the calculator says B is 147.195, and the value that it gave for C there was actually negative. So instead of doing what a human would do and just discarding it, I decided to add another constraint. So instead of just B being between 0 and 180, I said and C is greater than 0. It kicks out that extraneous solution, so we just get the one we want. And one more example, just to show you this actually will work on the obtuse case. So I did A is 125 degrees, 125 degrees. Side A is 50, and B is 44. So if you think about it, that's actually just obviously the one triangle case, because it's obtuse and the side opposite is greater than the other side. But I asked the calculator to solve it for me. So here's my system, rather. And then the calculator solved it. The calculator, again, does the thing where it gives you an extraneous solution that you, as a human, know that you're not going to count. But the calculator, unless you give it the additional constraint, doesn't know that. So there you go. B is 46.125 and C is 9.41699. Remember, you have to solve for the additional angle. But this does most of the work for you. It's kind of neat. It allows you to avoid the ambiguous case. So it's kind of just a shortcut, maybe. I'm not really sure what I would classify this as. So this is, again, just in case you want to screenshot this or something, this is the general setup and where the idea comes from. I hope you found this interesting and helpful, and good luck.